Hey, hello everybody. My name is Vesa Linja-aho and I'm here to talk about the fire safety of hybrid and electric vehicles and the fires in Finland in 8 years of my background. I'm an electrical engineer and worked the last decade as a senior lecturer of automotive electronics in University of Applied Sciences, Helsinki Metropolia. And after that, I have been working as an independent electrical safety professional involving in both national and international standardization of electrical safety for charging systems and electric vehicles, and published some national textbooks and handbooks. As every new technology, electric vehicles introduce new risks, and all modern vehicles with electrified powertrain, they withhold an electrical safety risk. The risk is mainly for mechanics. Normal user or rescue staff cannot get an electric shock or an arc flash accident from an electric vehicle. But the large lithium-ion batteries utilized in plug-in hybrid vehicles and battery electric vehicles pose a risk for thermal runaway and battery fire. And modern lithium-ion batteries, they always have the small risk for a thermal runaway and a battery fire. It's very hard to extinguish. Here is a picture of the underbody of a modern battery electric vehicle. There is those orange parts are the high voltage parts. Here is the charging inlet on the left. Then there is an electric converter for the motor, and then in the very bottom of the vehicle there is the lithium-ion traction battery. The traction battery design varies by car make and car model, but the basic idea is the same. There are lithium-ion cells ordered as modules, and the modules are connected in series, and they achieve like 400 or 800 volts of voltage. And there are several structural choices to ensure the vehicle will withhold normal crashes in city speeds, and also there is adequate cooling for the battery and heating also for cold countries. And one other point in this kind of structuring is that if there are some modules go into thermal runaway, it does not spread to adjacent modules. For vehicle fires, usually the reason is usually electrical fault, or then something flammable gets to a hot surface. If you have a gasoline vehicle, the exhaust system, the manifold and the piping, they are very hot. And if fuel or oil or any plastic which is flammable gets in touch with those hot parts, it can start a vehicle fire. Also, jammed brakes or faulty bearings, especially in heavy vehicles, might cause vehicle fires. All mechanical parts which generate heat, they can start a fire. For electric vehicles, we don't have those exhaust manifolds if it's a pure electric vehicle, and then we have the high voltage system which can cause a fire, or then the traction battery can catch a fire. It's typically an internal fault in a single cell in the battery, or then an external impact such as severe crash can cause a thermal runaway in the battery. The exact reason, if we compare building fires, structural fires and vehicle fires, the exact reason in vehicle fire, it's usually we cannot determine it because vehicles usually they burn so badly, so the temperature is so high, and then they burn completely, so that it's difficult to investigate the exact reason from the vehicle. From structural fire, it's usually simple to find the exact reason, but vehicles it's not, and usually the vehicles which burn completely, they are not very expensive or new, so there is no point in conducting €2,000 fire investigation to a vehicle which costs €2,000. The insurance company is not willing to pay it. If the vehicle catches fire while driving, which happens also, you can, by interviewing the occupants and the driver, you can find out what was happening. Was there, for example, white smoke from the underbody? It tells about a thermal runaway in the battery. Here is one example of a burnt electric vehicle in Finland. It was a hybrid, plug-in hybrid electric vehicle. It burned totally. It started smoking while driving, and then there was some error lights, malfunction lights, and then it stopped and it burned completely. And here is another picture. So it's very hard to try find out the exact reason. The best suspect is an internal fault in the traction battery, which is in the rear part of this vehicle. Why this is important? Electric vehicle fires are difficult to extinguish because if you have a normal car fire, it can be extinguished with like 500 liters of foam or water, and it won't reignite after you have put it out. But if you have a lithium-ion battery, as modern electric vehicles do have, where the plug-in hybrids or battery electric vehicles, there is virtually no way, if a lithium-ion cell goes to a thermal runaway, it's virtually as hard to extinguish as you were trying to extinguish a firecracker or a other kind of fireworks, because lithium-ion cells, the cathode material, it's lithium-based oxide or lithium iron phosphate, which when it heats up, it will release oxygen to withhold the fire. So only way is to try to cool the battery with water so that the reaction does not spread to adjacent cells. And the mostly used method for electric vehicle fires is to use traditional equipment the fire brigades have. It's the fire hose with a branch pipe, and you have to use lots of water to keep the battery cooling down. There are also several competing methods or tested methods, like immersing the vehicle in a water pool or penetrating the battery with a lance which will feed water inside the battery, or using large fire blankets, or using alternative extinguish agents like Novec, for example. All these have been tested. There is not very much scholarly research on these extinguishing methods because it's very expensive to, it's cheap to test one cell in a laboratory, but testing full-scale vehicle fires, it's expensive. And all these methods which have been tested, they usually don't work very well, or they are inefficient compared to the price which you have to pay. For example, those crates for immersing vehicles, they are expensive, and there is no point in for every fire brigade to buy those. So the traditional methods work quite well. And in this study I conducted, I mined in Finland, every fire brigade mission is recorded in a specific database. Researchers can get access to that database, and electric vehicles are not logged in specifically. So when the fire brigade records the fire, they don't check if it is an electric vehicle or a conventional vehicle, but you have to mine the database with keywords related to electric vehicles, such as using the keywords which tell about model or make of electric vehicles, or use words like battery, traction battery, thermal runaway, lithium, or such words. And still you get lots of false positives. For example, you can mention the battery even if it's the normal vehicle, traditional vehicle. And then I had to classify the incidents. I found the electric vehicle, hybrid vehicle fires, and then analyze how they were extinguished. Here are some results in the table form. There are Finland is we have 2.7 million passenger vehicles in Finland, and the population in Finland is 5.5 million. So we have lots of vehicle fires. For example, normal passenger cars, there are about 1,300 fires every day. It's quite a lot for a small country. And the incident rate, which is usually used for comparing vehicle fires, incident rate in a year per 10,000 vehicles, it's 4.6 for passenger vehicles. It's the same for vans and pickups. Trucks and buses have a higher rate because they are used, like normal passenger car is used for maybe 1 or maximum 2 hours per day, but trucks and buses run trucks run for 8 hours or more, and buses even more, city buses and things like that. For the electric vehicle fires, there are not very much of them, as the electric vehicles are not very common in Finland. In Norway, they are much more common. There are like 80% of new cars are electric in Norway, but in Finland it's 50% only from new cars. And the total number of battery electric vehicles, it's in parentheses here, 80,000 or 81,000. Plug-in hybrid vehicles, 130,000, and then normal hybrid vehicles are, this is an approximate number because the number or the fact if the car is hybrid or not, it's not logged in to the vehicle database. So there has been many years with no battery electric vehicle fires, but this year there have been 4, and for plug-in vehicles, plug-in hybrid vehicles, 8 fires. Still, the incident rate is very low compared to this base rate for vehicle fires, which is 4.6. We can see that even when there has been a big increase in battery electric vehicle fires, 4 fires this year. Of course, the last 3 weeks are not in the statistics because the year has not ended yet, but 4 fires this year, so the incident rate is 0.5. It's very low compared to this 4.6. One plausible explanation why these are so uncommon is that the electric vehicles are quite new. So new vehicles, we know from other studies that the probability for vehicle fire, it increases when the vehicles get older because the electrical joints wear out and there is corrosion and things like that. But still, electric vehicles fires, there is a tenfold difference if compared to traditional vehicles. And one observation was that all the fires have been extinguished with a traditional branch pipe system. You don't need special tools to extinguish electric vehicle fires, and you have to just use lots of water to extinguish them. Electric vehicle fire might take like 10-fold of water. Like if you need 500 liters for normal vehicle fire, you might need 5,000 liters for electric vehicle fire. The actual fire can be finished with like 1,000 liters, but still you have to cool down the battery after the fire. Only one of the incidents was crash related. It was like the car was driven out of the road. It fell 5 meters on a rocky terrain, and then the battery was damaged below and it ignited. As a conclusion, the fire risk is lower for electric vehicles till date. We don't know what happens in 10 years when they get older, but now it's lower. And the main point for extinguishing those fires is that you have to have trained personnel to apply a lot of water. It's not over when you have first ignited it. Couple of the fires, the vehicle reignited after finishing it. Here is one example of a crash test. This is a Nissan Leaf crashed 75 kilometers per hour to a stiff pole. The battery did not ignite, but this just tells that it doesn't ignite every time, because that ignited vehicle in that 5 meter fall down, it was also Nissan Leaf and it ignited. So all accidents are different, and when you have bad luck, it can ignite. As a last slide, I will show one workshop incident in Finland. This was not a vehicle fire, it was just a battery being fixed. There is 6 60-volt modules in series in the battery, and here is the correct way for wiring them. You connect them in series. But then the mechanic was distracted and accidentally connected 2 60-volt modules as a loop here. So plus minus, and you know, if you have 2 9-volt batteries and connect them like this, they will start smoking, and here the wire started smoking, and also 3 or 4 cells were going into thermal runaway, and there was 2-meter flame according to that mechanic. We don't have any video or surveillance camera video on this incident, but the mechanic said that there was a long burst of flames from one of the cells. So thank you for your time.